Greetings. In this problem, we want to calculate the radius of a molybdenum atom, knowing that it has a body-centered cubic cell and the density is 10.26 grams per mil. Now, when we look at the overlay up there, what you can see is that the length of the cell is A, B is the diagonal across the face, and C is the diagonal through the body, and that forms the right triangle. And we're going to need to calculate C because that travels through the two cells in the corners plus one in the center, so that's 4 times the radius. So the technique is the same as it's always been. Step 1 is calculate volume of the unit cell. The second step is calculate length of the unit cell. The third step, what we're after, is to calculate C, and to note that C equals 4R, okay? And then we calculate for R, okay? So first off, we need to go back and ask ourselves how many atoms are in a unit cell. And we can see that there are 8 eighths in the corners and 1 in the center. So there are 2 atoms of MO per unit cell. And we then can convert that to moles, and we know that there are 6.022 times 10 to the 23rd atoms per mole of MO, and that tells us how many moles there are in the unit cell. Now we can convert our moles to mass with the formula weight, which we can get off the periodic table, okay, and that would be 95.95 grams of MO per mole of MO. And we now know how many grams are in the unit cell. And then if we use the density, a macroscopic measurement that we can measure, we can convert our mass to our volume. And we are going to actually divide by the density. So we have 10.26 grams per ml of molybdenum. And remember, ml milliliters is centimeters cubed. We get out our calculator, which I've already done the math, and we come up with 3.11 times 10 to the minus 23rd. Now, in the next step, we're going to convert this to length. So I'm going to write ml as centimeter cubed per unit cell, and I'll use UC for unit cell, okay? Okay, now we want to go to the second step now that we've calculated the volume. And we know that for a cube, the volume is equal to the length cubed. So we're going to say that the length is equal to the cube root of 3.11 times 10 to the minus 23. And I usually go 1/3, recognize that's the same thing as cube root, and then I recognize that this is 0.33333, so I take it to the power of 0.333, and I get 3.14 angstroms. Now, when we look at the image up there, okay, and please look it up there, but what we've got here, since I can't draw up there, is if this represents the face, okay, this is what we're going to call B. And then if this is one of the edges, this is what we're calling A. And then the diagonal going through the center is what we're calling C. So this is equal to A as right there, the length. Now we need to calculate B, okay? What we know is that we have on the face a right triangle, where B is the hypotenuse across the face, the diagonal across the face. So we can say B squared equals A squared plus A squared. So B is equal to the square root of 2A squared, which is equal to the square root of 2 times 3.14 squared, which is equal to 4.44 angstroms. Okay? Now that we have that, we can calculate C. We have another right triangle, okay? So this is the right triangle that we just covered, the one on the face. And this is the right triangle through the body. So we can now say that C squared equals A squared plus B squared. So C is equal to the square root of A squared plus B squared, which is equal to the square root of 3.14 squared, that's our A, plus 4.44 squared. And we get C is equal to 5.44 angstroms. Okay? Now we know this, and when we look up there, we can see that there's one radius here, then you have the atom in the body, and then which has two radius, and then one radius up here, which is the atom in the other corner of the diagonal through the center of the cubic cell. So we can say that C equals 4R, therefore R equals C over 4, which equals 5.44 over 4, which is equal to 1.36 angstroms, okay? And remember, an angstrom is 10 to the minus 10 meters. It's not an SI unit. It's only for length. And hopefully you see the method for solving this. And although it looks a little bit complicated, when you think your way through it, it's very basic, okay? So good luck, and I hope that helps.